Hello everyone, welcome back to codingscientist.com. You are watching World of Sensors using Arduino UNO and the sensor shield from Seed Studio along with the sensor kit. Alright guys, we are going to look at a very interesting sensor in this particular lesson, and that is called the 3-axis accelerometer sensor. So what is a digital accelerometer? So basically it's a there are actually multiple axes, 3 axis available, 6 axis available, 9 axis available, the MPU 6050, the modules, sensors which are available in the market are pretty good one. Here we are using a 3-axis digital accelerometer, which is the key part in projects like orientation detection, gesture detection, motion detection, and multiple other aspects of the robotics field. Especially in robotics, this is highly used, all right, even in the drones. So this 3-axis digital accelerometer is based on Freescale's low power consumption module using MMA7660FC, which is a kind of sensor, and there is an associated library which we need to download, right? So it features up to 10,000 gram high shock survivability and configurable samples per second PCR rate, that is the per second rate, for generous or a generic applications that don't require too large measurement range. This is basically one of the great digital accelerometer I have personally seen, guys. I worked with these sensors, the accelerometer sensors widely in most of my robotic projects. You can see around my lab there are ton loads of bots. Most of my bots use the digital accelerometer. Of course, I do use MPU 6050 and also from several other brands which are available, like SparkFun's 9DOF sensor. But this particular module, it's so easy and flawlessly it gets integrated and stuff. It's fantastic. So go ahead and pick up the sensor from your kit and plug it into the I2C port. So this requires a I2C detection, right? So let me show you what I have done, and you can take a look at the sensor as well. So this is the sensor, guys. So this is the IMU. You can call it as a IMU or digital accelerometer sensor basically, right? So this is how it looks. You can take a close look at the sensor module, and this is the back side. This is the port where you plug your wire, and then this is connected to I2C port. You can use any of this I2C port, doesn't matter, 1 2 3 4. There are 4 I2C ports, so you can connect to the first one just for ease. And then now it's time to move on to our code. Let's download some library. Let me show you. So go to my GitHub repository, go to Arduino sensor library, and in sensor libraries you need to go to the first one, which is accelerometer MMA7660 master zip. So this is the accelerometer library. Download this library, it's pretty huge one, and then make sure place the zip file, extract the zip file and place it into your Arduino library folder. Wherever you install your Arduino IDE, make sure it's in exactly the same location, or else it doesn't work. And then what you need to do, go to the codes section, which is in Arduino sensor projects within my GitHub repository. And then let's move on to lesson number 28, which is digital accelerometer. Click here, and this is about 32 lines of code, and it's not a complex code. It's very easy to understand. The orientations being has to be declared like x-axis versus y-axis. If you understand the logic, those of you from C++ background, it's easy to understand. If you don't understand, get back to me. I will be happy to explain to you line by line. Click raw and Control A, Control C, or you can Control copy as well. Open the Arduino IDE, and this is the code. Once you upload the code, which I have done already, now let's click on the serial monitor and check what is the reading. Wow, let me just close this again and open it. There you go. I can see x-axis, y-axis and z-axis. Let me just tilt it. Cool. The acceleration, can you see it guys? The acceleration changes as I change the orientation of the sensor. Let me just move to my other camera so that you guys can see what exactly I am seeing as I move the sensor. Alright, there you go. If I move the orientation, you can see the acceleration of XYZ changes. Let me shift. There you go. 95G, 38G, the X axis and Y axis. Cool. Fantastic. So the acceleration of XYZ and XYZ, all the three axes, because it's a 3-axis accelerometer, the reading is perfect. Fantastic. Great. Excellent. So guys, now you can imagine what kind of gesture control robot you can make. You can make a gloves and put the sensor and send the signal through your, either through Bluetooth BLE, or you can do through Wi-Fi, or you can also use infrared transmitter receiver. You can use multiple sensors to communicate guys, and you can change the orientation of the board as you change your hand with the sensor. All the 3 X, Y, Z axis, you can change the robot's direction. Amazing project, isn't it? If you want to build a project, get back to me. I will help you. I will see you soon in the next lesson. Goodbye.